Hello friends, in today's class we are going to talk about different type of schedulers like long-term scheduler, medium-term scheduler, dispatcher and short-term scheduler. Welcome again, and now we are talking about the different type of schedulers. And just to discuss this schedulers, you have again come back to this standard process transition diagram. Okay, process state transition diagram. So we have already seen this thing in detail in last class. Now, in this diagram, you notice that there is a ready state, and that is going for the dispatching to a running state, and then there will be a event wait, and then it is blocked, and then event occur, then it will be in the ready. So there are many things are there. The main thing is there must be some program that will take the data from the new state and put it into a ready state. That will take a program to a ready state. Okay, there must be some program that will select the process from the ready state and select it for the execution, right? So just to think over it, there should be this should be done by a program that will select the process from the new to ready state. If it is in the suspended ready, and that is basically reside in the disk, there must be some selection process. Right, there must be some selection process by which it will be suspended ready to a ready state. A lot of process can be there here, and they'll be waiting here, and then again after this, it when go to the ready state, it has to give the control of this CPU. Okay, so that is the dispatch unit that will that who gives the control. A program must be there that will give the control of CPU to process, right? So these different questions are there, and now this diagram looks very trivial, but there can be a lot of processes will be in the queue, right? There should not be a single process. So there will be a process, let's say P0, there will be P1, then there will be P7, not necessarily in the same order, and then will be P4. So there must be some sort of queue. So now this chapter, this particular topic deals with this queues and the entire programs that perform the selection process. Okay, and we will come back to this diagram, and I'll explain you that which scheduler comes where. Okay, so that state transition diagram will definitely going to help in that case. So process scheduling, and a process scheduler selects among the available process for the next execution of the CPU. So that is the idea, that which process will be going to execute next. That is a decision making, execute next in the CPU, and that decision will be taken by what? Process scheduler. Okay, now how the process can be scheduled, that depends upon the kind of type of process. Like different process scheduling algorithms are there. For example, there is a first come first serve, and then we have a SJF, shortest job first. Okay, preemptive and non-preemptive version. So we will learn this scheduling algorithm, but for the time being we are talking about process scheduler. While selecting the process for this execution or allocating the CPU, one thing must keep in mind in the scheduler, that it has to maximize the use of CPU, right? It has that CPU should not remain idle, right? It should not remain idle, and quickly switches process onto the CPU for time sharing, right? So we will share the CPU, and it has to maximize the CPU utilization. as I told you in this diagram that there may be several processes in the ready state, there may be several processes which are in block state, there will be only one process in the running state, there will be several processes in the suspended block state, there will be several processes in suspended ready state, right? Suspended ready is what? In secondary memory, or it is in the disk. So now we have a few queues are there, scheduling queues are there of the process, and that is a job queue. Job queue means job or process are synonyms. Job or process are synonym terms. So there is a process queue, and it is the set of all processes in the system, right? So that is a job queue. Ready queue is there, that set of all processes residing in the main memory and ready and waiting to execute. Now here job queue, you can think of that all processes in the system, and main location of this system should be in the disk, right? They will be waiting for this for their turn to be invoked by program or by user or by issuing the command. So we are having set of all processes and it resides in the disk, whereas the ready queue is the set of all processes residing in the main memory and ready for the execution. We have already seen the block state, and for that we have a device queue, set of the process waiting for that IO devices. We also have an event queue, that they are waiting for some event to happen, such as after all processing, okay, they are waiting for a click in a tab, right? So like finish, like if you have installed some software, then at the end it is push display a button and it is ask you to finish, or it will say ask you to I agree, right? So that is an event, and until and unless that event will occur, the process will be in the waiting state. Okay, so that is an event, and it is not related with something related with input and output. It is not related with this kind of input output, you can say, but event to happen, mouse click or mouse movement. Okay, so that is the idea of the event queue. So there are different queues are there. And here the queue is also there in the secondary memory. Okay, there is also a queue, that is a suspend queue and the job queue. Okay, so suspend queue and the job queue job queue is the set of all processes ready, and suspend queue is something that is to reduce the degree of multi-programming. We have taken out the few processes from ready to the suspend stage. Okay, so job queue is a more broader. Okay, job queue is set of all jobs, set of all programs, whether they are willing to execute or not, that does not matter. The job queue is set of all programs available, whereas suspend queue is forcibly taking out some program. Okay, some program from ready state to suspend ready. And the last class we learned the reason, and that is nothing but lack of memory. So this is how a ready queue will look like, and we have already seen process control block for processes, and that defines the process. So ready queue is having something like this: a queue manages by head and tail, and in that case you can have like here PCB7 and then PCB2, that is the head and that is the tail. So one by one process will be taken out, and it will be given to CPU for execution. Okay, similarly you have a message tape 1, unit 0, unit 1, there is a disk. You can say that this is in the disk you have PCBs, and that can be your suspend queue, you can say. Okay, this is your suspend queue, because they are having some information related with PCB, so they have already executed, just they are present in the disk. Okay, so that way there is a various ready queue and various other IO devices queues are present. Magnetic tape unit 1 and unit 0 and unit 1 is your IO device. This is the representation of process scheduling, that what exactly happened, and again this will give you a more idea of again the same thing that is called as a process transition diagram, right? So we have this term is coming again and again, process transition diagram, and what we are talking about is just the extension of this process transition diagram, or you say implementation of it. So you are having a job queue that is present in the disk, and from where you will take the process and put into a ready queue. You also have a suspend queue, which is forcibly taken out from the jobs from the ready queue and putting them into a disk. So this is a fresh job can be come to this ready part, or a job that is ready and lack of memory we are putting into the suspend queue. From here to here, that will be go to the CPU, and it will come out either as a termination or it will be blocked. Okay, so it is for waiting for IO request. Time sliced expired. Now this term is a new term, a time slice expired, and that we will learn in one of our scheduling algorithms. Right. Another reason can be for this forking a child, and forking a child is and it will execute the child, and another reason can be wait for an interrupt to occur. So that can take out a process from the CPU. Okay, this is how this a queuing diagram representing queues and resource and flows, right? So that is how it will look like. Now we have different schedulers are there, and among the different schedulers you have a short-term scheduler. You have a short-term scheduler, and you have a dispatcher. You have a long-term scheduler. You have a long-term scheduler, and also you have a medium-term scheduler. Medium term scheduler, right? So you have this many schedulers are there, and each are having different responsibility. Now just understand and grab this concept of schedulers. The short-term scheduler is also called as a CPU scheduler. Okay, so this is a CPU scheduler, and what is the responsibility of this CPU scheduler? It selects the process from the ready queue. Select the process from the ready queue and for execution. So selecting the process from the ready queue for the execution, it is the responsibility of your short-term scheduler. Okay, select the process. Select which process should be executed next and allocate the CPU. So now this will select the process from the ready queue and allocate. It is not the job of allocation. Okay, only the job here in this case is the selection part, selection from ready queue. Sometimes the only scheduler in the system, and it is invoked frequently in milliseconds. Okay, it is invoked very frequently in millisecond, and it must be very fast. So that is your short-term scheduler that will be select the process that who should be the next to execute. Then we have a dispatcher, and the role of dispatch, this term is always been used very here also you find that dispatcher, and dispatcher is the main process or program that will do what it will do. It will take the process that is selected by short-term scheduler. So now here it will select the process in one line, select the process from take the process selected from short-term scheduler and give control of CPU. Okay, so this is more related with giving the control of the CPU. So dispatcher module gives the control of the CPU to the process selected by the short-term scheduler. Okay, so now control of the process will be given by your dispatcher. So now understand the difference. One is only selection process, and second process is the nothing but the giving the control. So now there is the task involved in this, that giving the control to the CPU is switching context, context switching that we have done. Switching to the user mode. User mode allows them to execute user program, right? Execute user program, and jumping to the proper location of the user program and restart the program, right? So if it has been already executed, then we have to take the value of what? PC, and that is the program counter, and go to that place and finally execute it. So a lot of thing you have to switching context, even the saving the PCB, and then loading the PCB is the data structure last class we have seen, and so switching the context, switching to the user mode, and restarting the program. This will take some time, right? These three steps will take some time: switching the context, switching to the user mode, and jumping to the location, and that we call it as a dispatch latency, right? That is your dispatch latency. So what is dispatch latency? Time it takes for the dispatcher to stop one process and start another running. Okay, so whatever the amount of the time to stop the process, complete the 3-step 1 2 3 and restart it. Okay, and that is your dispatch latency. A long-term scheduler or the job scheduler. Okay, so now there must be some process. So short-term scheduler was taking the selection from the ready queue, okay, and who will be running next to the CPU, whereas long-term scheduler job is to select the process from disk, okay, from hard disk. Select which process should be brought into the ready queue, right? So that is the idea, that who will be brought into the ready queue. So there must be, there are new, again you have to look at this part, that there must be something that, like here, ready to running we have seen. So there are two programs are involved in here, is a short-term scheduler and dispatcher. I am talking about this process by which it is getting here. So this is one admit, a new process getting admitted, and this line also which says that activate, right? So the way they are activating either from the disk or directly by forking a new child. So that is the idea. And that is a select which process is brought into a ready queue. Long-term schedulers are invoked infrequently, seconds or minutes, maybe slow, and long-term scheduler control the degree of multiprogramming. Why such a huge statement is the reason here in this case is that degree of multiprogramming is number of process, right? Number of process reside in main memory, right? So if you are bringing more and more, if you want multiple processes to be present so that CPU can switch from one to another, then we have to brought multiple processes into the main memory, and that is how we can control what we can say that is the degree of multiprogramming. So if the long-term scheduler bring more and more process, then definitely degree of multiprogramming will increase. Now, so the selection criteria, when you are selecting a process, then what it should be. If you select a process which is having something like this, this is the time required, CPU time, and then small IO time, then we have a CPU time, then we have a small amount of the IO. So this is one process when CPU, okay, and we have another process we have required long time IO and then small time CPU, right, and then long time IO and then small functionality of CPU, right? So now what will happen is, if I select two processes of this category, right, think over it and then comment that if I select two processes of this category, then what will happen is they all required CPU for the longer period of the time. Right? So there will be very short time before they will get blocked and get be running. So each process will be running, it will utilize the CPU for the longer period of the time, and that is the thing, it is the targeting over here, that process can be described as either IO bound process, spend more time doing IO than computation, many short CPU burst, short CPU burst, and CPU bound process spend more time doing computation and few very long CPU bursts, right? Now, if you are choosing only CPU bound process, then it will not be a good idea, because at that time we have a IO device will be utilized very less. The long-term scheduler must strive for a good process mix, which is consist of what? Both, which is consist of IO bound process as well as what? CPU bound process, right? So it should be good mix of IO bound as well as CPU bound. So that is the summary, that dispatcher give the control of the CPU to a process. Short-term scheduler will select the process which should be executed next and allocate the CPU. Long-term scheduler select the process which should be brought into the ready queue. Process can be described as IO bound or CPU bound, and there should be a very good mix of it. In addition to that, we are having also a medium-term scheduler, and you might be thinking that I have explained everything, but here in the job long-term scheduler, the job was to taking out from the disk. But what about this one? What about this part? What about the suspension part? That is both the cases. The process will come from to the ready state, and for that we have addition scheduler, and that is known as your medium-term scheduler. The medium-term scheduler can be added if the degree of multiprogramming need to be decreased. That means if you want to take out some process out of this ready queue, okay, and swapping out where into the disk, okay, you want to put some of them in the suspend state, then medium-term scheduler comes into the picture. Okay, and what does is remove the process from the memory and store on the disk, bring it back in from the disk to continue execution, and that is operation that is called as swapping. So if you want to have less number of process in the memory, decreasing the degree of multiprogramming, then we invoke a medium-term scheduler. Lastly, for this particular topic is what should be the criteria of scheduling and optimization is that we want the CPU to be maximum utilized. We want maximum throughput. Utilization and throughput is number of process completed per unit time, that is your throughput. Minimum turnaround time, that the minimum turnaround time means less time required, less waiting time, you can say, right? We want it to be turnaround. So just complete the process. Minimum waiting time, that I already says that average time for process being waiting in the ready queue, and minimum response time, and that required in case of time sharing system, right? So there at times user wants also respond from the operating system so that it can understand everything is going on well. Okay, so minimum average response time, or we can have minimum maximum response time. Okay, either we have a minimum average or maximum average. Okay, that can be the criteria. So these are the scheduling criteria and optimization, on which each scheduling algorithm will be scrutinized. Okay, so we'll see the optimization, throughput, turnaround, minimum waiting, and the minimum response time. Okay, so that is about the scheduling queues, and you can say the last part is also important, scheduling criteria and optimization. Okay, so that's all for this discussion. Thank you.